Today we will resume our discussion about the three basic interpretation, the additional rules of probability, and then the multiplication rules and conditional probability. So the multiplication rules can be used to find the probability of two or more events that occur in sequence. If two events, A and B, are independent events, if the fact that A occurs does not affect the probability of B occurring. So we have the first rule here. We need to multiply. If the both events are independent, just need to multiply the first event. Okay. So the first event times the second event. Okay. That is the first rule. So, for example, a coin is flipped and a die is rolled. Find the probability of getting a head on the coin and a 4 on the die. We all know that getting a head and a 4 is independent events, so you just need to multiply the probability of getting a head, wherein the total number of outcomes of that is 2 over the number that will appear is only 1 because we have just 2 samples pair or the outcomes, 2 lang, total number of outcomes, times the second event or the independent event we're in, that is a 1/6. So we compute for the probability of getting a head in a 4, so that is now equal to 1 over 12. Okay? So note that the sample space for the coin H, so head and tail, and for the die is 1, 2, 3, 4, 5, 6. So here is another example of the multiple rule number 1. So we have a card that is drawn from a deck and replaced. The second card is drawn. Find the probability of getting a queen and then a ace. We all know that the probability of queen is 4 over 52. The probability of getting a queen is 4 over 52. Since the card is replaced, automatically independent event pa rin siya. So the total number of outcomes there and the probability of getting an ace is 52 pa rin. And since the getting a queen and an ace does not affect the second, yes, the second card, or since the card is played, the probability of getting an ace is 4 over 52. So it does not affect the second event. So you just need to multiply it. Okay. Also, another example, a Harris poll found that 46% of Americans says that they suffer great stress at least once a week. If 3 people are selected at random, find the probability that all 3 will say that they suffer great stress at least once a week. So take note, given sa atin, yung percentage, which is 46%, yung stress daw, if 3 people are selected at random. So it does not affect that is not dependent to each and every one. So, yung tatlong people, so the first one is 46%, the first people, the first person, the second, and the third. So, this is all independent events, so you just need to multiply. So, the answer now is 0.097. Another one. So, approximately 90% of men have type of color blindness that prevents them from distinguishing between red and green. If 3 men are selected at random, find the probability that all of them will have this type of red-green color blindness. So take note, this is in percentage, also the 9%, and also 3 men are selected at random. So the first person does not affect the second, so independent event, you just need to multiply the probability of each man. Okay, so selected at random, so the probability of that all of them, or the 3 men, will have this type of red-green color blindness is 0.072. Also, if the first rule is discussed, is more focused on an independence event where you just need to multiply the first event, the second or third event, as long as it is an independent event. So the second rule now, when the outcomes or occurrence of the first event affects the outcome or occurrence of the second event in such a way that the probability is changed, the events are said to be dependent events. Okay? So we have the conditional probability of an event B in a relationship to an event A is the probability that event B occurs after event A has already occurred. So take note, the probability of getting the first event and the second event, take note, when these two events are dependent, we have this, the probability of the first event, and after that, the probability of second event after the first event had occurred or had occurred. Okay? For example, at the university in Western Pennsylvania, there were 5 burglaries reported in 2003, 16 in 2004, and 32 in 2005. If the researcher wishes to select at random 2 burglaries to further investigate, find the probability that both will have occurred in 2004. So take note, the first event here, is okay, the first event is selected at random. So, dalawa daw. So, the first event is, ilan yung burglaries natin? 5. 5 burglaries in reported in 2003, 16 in 2004, and 32 in 2005. But the problem, the probability that both will occur in 2004. So, we focus on the 2004 case. So, that is 16. So, that is the total outcome or the probability of getting that over the total outcome we're in. You just need to add all these burglaries from 2003, 2004, and 2005, the 5, the 16, and the 32. So that is now 53. So that is the first event we're in 2004. So the probability of that first event, burglary, so 15 over 50, 16 over 53. Since the second, that is the first case, is selected. Since the first case now is selected, that is not replaced now. So, mababawasan yung total outcomes mo, which is 52, and also the total number of burglaries in that year. So, this is now the dependent event to the first. Okay. So, that is now the first event times the second event, the probability of second event after the first event had occurred. So this is now your answer, 60 over 689. Another example. So 3 cards are drawn from an ordinary deck and not replaced. Find the probability of these events: getting 3 jacks, getting an ace, a king, a queen in order, a club with spades, and in the heart in order, and getting 3 clubs. So what you will do is first, the first event is getting 3 jacks. So since the card is not replaced, automatically your cards is also, the total number of outcomes also is decreasing, as well as also the number of the probability of that event. So we have the total number of jacks in the deck of card is 4. So automatically in each draw, you just need to minus or subtract 1 because the card is not also replaced. So the probability of getting 3 jacks now is 1 over 5,125. Okay? The second one is the probability of getting an ace, a king, and a queen. So take note, there are 4 ace, there are 4 king, and 4 queen. So sa taas, hindi naman nakaka-apekto. Excuse me. So we have ace, king, and queen. But take note that the total number of deck of cards here is decreasing. So because the card is not replaced. Okay, so the answer for that is 8 over 16,570. And also a club, a spade, and a heart. We all know in the deck of cards, a club is 13, the total number of that, and spade also, and a heart. Take note also that the card is not replaced, so dependent to, makaka-apekto sa susunod. So, the total number of outcomes sa baba is decreasing. Just need to multiply that. That is the second rule, multiplication rule of probability. And also the probability of 3 clubs. So, we all know that clubs has 13 in a deck. Parehas to sa jack, wherein it is also decreasing. So, 13, 12, and 11. So, kasi pa isa mo siyang nawawala sa deck of cards and also the total number of actions. Okay? So, conditional probability. So, we have discussed the multiplication rule number 2 and also now the conditional probability. So, the conditional probability of an event B in relationship to an event A was defined as the probability that event B occurs after event A has already occurred. So, this is the formula wherein the probability of the second event after the event A was defined. So that is equal now to the probability of both events, A and B, all over the probability of the first event. To furtherly understand that, here is an example. So, given sa atin yung a box contains black chips and white chips, a person select two chips without replacement. If the probability of selecting a black chip and a white chip is 15 over 56, and the probability of selecting a black chip on the first draw is 3/8. Find the probability of selecting the white chip on the second draw, given that the first chip was selected was a black chip. Take note sa problem natin, given sa atin yung selecting a black chip and a white chip. So this is now your combined probability or the probability of the first and the second event. So given sa atin, which is 15 over 56. And also, the first drawer in the black chip was selected. So this is now 3/8. So how do we find the probability of this? So given daw sa atin yung selecting white chip on the second draw. Okay? So white chip, black chip, and the white chip. The probability of getting the white chip after the black chip was first drawn, it is just equal to probability of getting the black chip and the white chip all over the first event, which is the probability of getting the black chip, which is given in the problem. So we have 15 over 56, which is given in the problem. Okay? And also the probability of getting a black chip now is also given in the problem. So 3/8. So we have now 5 over 7. So the probability of selecting a white chip on the second draw is given that the first chip was selected. So the chip was selected was black, so that is 5 over 7. Another example. So a recent survey asked 100 people if they thought women in the armed forces should be permitted to participate in combat. The results of the survey are shown. So given sa ating yung table, we have the gender in the male and female, the total number of yes and no. So the first one, the respondent answered yes, given that the respondent was a female. The second is the respondent was male, given that the the respondent answered no. In the first event, in the first required in the problem is the respondent answered yes, given that the respondent was a female. So take note, the first event here in number 2 is female. So female, that is the first event. So the probability of getting the yes. So, kung sino daw nag-yes, given that the respondent was a female. So, this is the second event. The first event, I mean, female yung given. So, pinapahanap sa atin to, conditional probability. While the second also, the respondent was a male, given that the responder answered. So, ang probability na hanapin natin dito is the probability of getting a male after the first event occurred, excuse me, which is the people or the respondent that has answered no. So this is the conditional probability. Okay. So what is the solution? So the first one, sabi ko nga, let M be the respondent M, F is the female, Y is for yes, and N is for no. The problem is to find the probability of the respondent that answered yes, given that the respondent was a female. So take note, in the conditional probability, you just need to divide the probability of getting both of that. Getting the probability of getting the two events. So probability of getting a female and a yes. All over the first event, which is discussed also, which is also given the problem na stated naman doon na given that the respondent was a female. So that is the first event. Okay? So the probability of having the female and a yes is a number of females who responded yes. Okay, take note in the previous slide that it is the total number in the table. So kung makikita niya, balikan niya. That the table now is 8 and the total number of respondent is 100. So yan yung nagsagot na female at the same time nag-yes siya. So 8 over 100 is the total number of outcomes or the respondents there. So we have now the conditional probability of having those female and the yes. And the first event, the probability of getting the first event is the probability of selecting a female. Balik tayo dun sa table, makikita nyo doon that the probability of getting a female is 50 over 100. Okay. Then, we need to compute now for the probability of those people or those respondents that had answered yes after the first event, which is the probability of selecting a female. So, since alam na natin that the probability of getting a female and at the same time those who have answered yes, so that is 8 over 100. 8 over 100, and also the probability of having female that is also in the table is 50 over 100. Okay, so the answer now is 4 over 25. So this is not the conditional probability in the answer. Okay, and also in finding the probability of the second, so we need to find the probability of those respondents who are male after the first event, which is the probability of those respondents who have answered no. So this is now the conditional probability of first event, of the second event after the first event had occurred. So the probability of both event has occurred. Okay? So makikita nyo to. So dun sa table, you just need to add, I just need to see where the people who have answered no at the same time male, makikita nyo dun is 18. At the same time, the probability of the 18 over 100 class yung probability niya. Okay? And also the probability of getting the first event, which is equal to 60 over 100. So the answer now is 310. So in conditional probability, you just need to focus what was the first event and the probability of getting that first event and second event. Okay. So this is an Venn diagram which is illustrated. So this is the total probability or the sample space. So this is the probability of getting an A, the first event, and the probability of B, the second event. So kung saan sila nag-coincide, so the shaded part or the darker blue, so that is now the probability of getting an A and a B. So this is an example of probabilities wherein at least words are indicated. So when trying to solve the at least probabilities, so we need to compute first for the complement of that event. After, you just need to minus, then you can have now your answer. So this is an example of that. A game is played by drawing 4 cards from an ordinary deck and replacing each card after it is drawn. Find the probability that at least one ace is drawn. So sabi dito, it is much easier to find the probability that no aces are drawn. So the probability of losing ace, and then subtract the value from 1, then to find the solution directly, because that would involve finding the probability of getting 1 ace, 2 aces, and 3 aces, and 4 aces, then adding the result. So take note, the complement of that event, so alam naman natin na at least, take note the word let E is the at least 1 ace is drawn, and also the E bar is no aces is drawn. So take note, we find the probability of that or the complement of that event. So 48 over 52, since the card is replaced every time. Okay, and also the probability of not getting an ace is always equal to 48. So this is now the probability of that. So when the word at least is found in the problem, you just need to find the complement of that event. After that, you just need to subtract that from 1. So 1 minus the probability of losing. So we have now 27, 0.27, or a hand with at least one ace will win about 27% of the time. Another example is a coin is tossed 5 times. Find the probability of getting at least one tail. So take note of the word at least. Okay. This is the at least one tail. So it is easier to find the probability of the complement of that event. We all know that the complement is the kabaliktaran of that event. Okay, kabaliktaran. So ano kabaliktaran yan? So getting all heads, okay, then subtract the probability from 1 to get the complement or to get the probability of at least one tail. Then you need to compute for that. So we have now the probability of getting at least one tail. So that is 1 minus the probability of getting the all heads. So the probability of getting all heads is 1/2 raised to the 5th because the card is drawn 5 times. I mean the coin is tossed 5 times. Automatically 1 minus 1 over 32 is 31 over 32. So that is now the probability of getting at least one tail. So that is all about multiplication rules and the conditional probability and the probability of having at least words. Okay, so many times a person must know the number of all possible outcomes for a sequence of events. So to determine this number, so three rules can be used. So we have the fundamental counting rule, the permutation rule, and the combination rule. So continue. So the fundamental counting rule, so we all know that in a sequence of events, and events of which the first one has the k possibilities, the second event has the k2 possibilities, and the third, and so on and so forth. The total number of possibilities of the sequence event will be, so you just need to multiply all the events and event k and events. So in this case, and means to multiply. Okay. For example, here a coin is tossed and the die is rolled. Find the number of outcomes for the sequence of events. We all know that we have two in a coin, we have two outcomes, which is the head and the tail. While in a coin, there is always, where in a die is rolled, so meron palaging anim. So the total possibilities of that is also 12. So a tree diagram was shown here so that you can see how correct is the frequency numbers or the sequence of events shown. Also, another example of this is a paint manufacturer wishes to manufacture several different paints. So the categories include the color type and texture. So how many different kinds of paint can be made if you select one color? One type, one texture, and one use. So take note, we have the first ano, total number of outcomes. So you just need to multiply, you just need to count all the colors. So how many is it? So 7, 2 types, 3 textures, and 2 hues, indoor and outdoor use. So the total now is 84. So that is the total number of outcomes in the sample space. Also, we have the factorial notation, which is also discussed in your senior high. So we have 5 factorial, 9 factorial. So these are the factorial notation. So a factorial notation is an exclamation point. So uses the exclamation point, wherein 5 factorial is equal to 5 times 4 times 3 times 2 times 1. So to use the formulas in permutation and a combination rules, a special definition of 0 factorial is needed. So 0 factorial kasi is always equal to 1. Okay? That is always equal to 1. So suppose the business, okay, wishes to rank 3 of them in 5 locations. How many different ways she can rank them? Using the fundamental counting rule, so she can select any of 5 for the first, then 4 for the other, and finally the remaining locations for the third choice. So we have 5, 4, 3, so 60. This is an example of the fundamental counting rule. So, permutation class. So, alam niyo na to, is an arrangement of n objects in a specific order. So, the arrangement of n objects in a specific order using r objects at a time is called permutation of n objects taking r objects at a time. So, it is written as NPR, or the permutation, which is equal to the number of objects taken at a time, divide or n factorial over n minus r factorial. Okay? So what is the example for this? So in a specific order, take note that a television news director wishes to use 3 news stories on the evening show. One story will be the lead story, one will be the second story, and one last will be the closing story. If the director has a total of 8 stories to choose from, how many possible ways can the program be set up? Since the order is important, the solution is, so the total number of stories, so that is n, so 8 stories taken at a time, so 3, so 8 permutation ng 3, so that is now 336 ways to set up the program. Another example is a school musical director can select 2 musical plays to present next year. One will be presented in the fall and one will be representing in the spring. So if she has 9 to pick from, how many different possibilities are there? Take note that the order is important, so pinakita na may pwedeng sa fall and the other in spring. So this is the total number of 9. So, meron siyang 9 musical plays, pero dalawa lang naman talaga. So, 72 different possibilities ang pwedeng mangyari. Also, combination, that is also a selection wherein a distinct objects without regard to order. So, combination siya used when the order is or arrangement is not important, as in selecting. So, we have this, the number of combinations of R object selected from n object is denoted by NCR. It's given from the formula, so n factorial over n minus r factorial. times the R factorial. So, R objects, kung ilan yung objects natin. So, how many combinations of 4 objects are there taken 2 at a time? So, just need to substitute properly the combination. So, wala naman tayong formula. But take note, meron tayo ditong R objects. So, just need to multiply that. Okay, so the number of that combination is 6. A news editor has received 8 books to review. He decides that he can use 3 reviews in his paper. How many different ways can 3 reviews be selected? So take note that the number of combinations of 3 objects taken from 8 books. This is now 56 possibilities. So what if, so this is the summary of counting rules wherein the fundamental counting rule, you just need multiply all, and also the permutation rule wherein it specifies the specific order or arrange order, in the combination rules wherein the order is not important. So just need to infuse this. So last but not least, the probability and counting rules. So this is now a combination of the probability and counting rules. For example, a box contains 24 transistors, 4 of which are defective and apat daw doon ay defective. If 4 are sold at random, find the probability of following probabilities. Exactly 2 are defective, none is defective, all are defective, and D, at least 1 is defective. Okay, so how do we get that? So there are a total number combination wherein the number of ways is to sell that is 24 combination 4. Kasi 24 yung transistors natin, 4 na beses natin dyan ibebenta. Excuse me. So, ang denominator natin palagi is this one because that is the total number of ways to sell that transistors. Since the first problem, exactly 2 defectives ang pinapahanap natin, stated sa problem natin that there are 4 defective, 4 defective, so dalawa, exactly 2. So, since this is the first way to sell that combination, after that, we need to sell that into the 2 non-defective ones. Kasi, bakit 2? Kasi 4 minus 2, 4 na beses mo siyang ibebenta. Dalawa yung defective. And bakit 20? Kasi 24 minus 4, that is 20. Bakit 24? That is the total number of transistors. So, gamit na natin siya because defective yung 4. So, 20 yung hindi defective. Kasi sinabi dito exactly 2 defectives. So, over the total number of ways to sell that, so this is down the answer. 190 over 1170. And the second one, the probability of getting no defectives. Since the problem said that this is no defective, automatically, lahat ng hindi defective, so that is 20, diba? Yung non-defective. And also that is 4 ways to sell that all over the total number of ways to sell that. So this is now the answer of the probability of getting no defectives, as well as the number of ways to choose 4 defectives. Ibig sabihin, lahat mo makukuha ay defective. Sabi ko nga, apat yung defective natin. At the same time, 4 na beses tayo magbibenta. So that is 4, the number of combination 4 objects or the 4 transistors taken at 4 defectives. So 1 yan, 1 over the total number of ways to sell that, which is now the combination of 4 objects taken from 24. Okay? So this is now the probability of getting all defectives. And also, finding the probability of at least 1 defective, sabi ko nga, you just need to 1 minus the complement of that event. What is the complement of that? Is the probability of getting no defectives. Since we all know that the probability of getting no defectives is 20, because alam natin 4 yung defective, ma-minus mo lang sa 24, 20, and 4 na beses tayo magbebenta. That is taken 4 at a time, all over the total number of outcomes or the ways wherein we can sell the transistors. So 1 minus of that, or the complement of that, getting at least one defective. So this is now your answer. Okay. Also, another example, a store has 6 TV graphic magazine and 8 news time magazine on the counter. If two customers purchased a magazine, find the probability that one of each magazine was purchased. Probability of getting one TV graphic and one news time. So, ilan yung total number of graphic magazine natin? 6. So, the combination of that taken at 1, kasi isa lang daw. And also, 8 news magazine, isa lang din daw yung dapat makuha natin. So, 6 times 8. And also, the total number of ways to select that. So, ilan silang lahat? 6 plus 8, that is 14. And also, dalawa. Kasi 1 TV graphic and 1 news. So, the answer now is 48 over 91. Another example, there are 8 married couples in a tennis club. If one man and one woman are selected at random to plan summer tournament, find the probability they are married to each other. So, this is an example. There are 8 ways to select the man, and 8 ways to select woman. So, 8 times 8, there are 64 ways. And also, when we have to select one man and one woman, since there are 8 married couples, the solution is 8 married couples. So, combination yun over 64 now is equal to 1/8. Okay?